Okay, let's look at the last example. We have f of x equal x squared over x squared minus 1. All right, so we want to first look at information from f of x, as usual. So first we'll look at x-intercepts. Well, that occurs when the numerator is 0, so the numerator is 0 at x equals 0. And that will also be the y-intercept. So 0, 0 is the x-intercept and the y-intercept. We also, in this case, we have some vertical asymptotes because of that denominator. And that occurs when the denominator is 0, and that will be x equal plus or minus 1. All right, and then let's talk about the end behavior. Well, the limit as x goes to infinity and minus infinity, in this case it's the same, of x squared over x squared, just taking the leading terms, is equal to 1. Okay, that means we do have a horizontal asymptote of this y value of y equal to 1, that horizontal line. All right, let's calculate f prime of x now. Okay, so now we're looking at f prime of x. So f prime of x, let's use the quotient rule. So in the denominator here we have x squared minus 1 squared, and we put x squared minus 1 in the numerator. Now here we have the derivative of the numerator, which is 2x, okay, minus the derivative of the denominator, which is also 2x, times the numerator of x squared. All right, if we simplify that, here in the numerator we have 2x cubed minus 2x minus 2x cubed over that denominator. So what's that equal to? Well, that's minus 2x in the numerator, and in the denominator, x squared minus 1 squared. So we want to know when this is 0. Well, it's 0 when x equals 0, just when the numerator is 0. And so to do our plus minus analysis, we put the zeros of the numerator and denominator on the number line. Okay, so we have x equals 0 there, and we have 1 and minus 1. These are our vertical asymptotes, so I'll put open circles there. Those are our vertical asymptotes. And if we do our plus minus analysis, to the right of 1, let's say we substitute in 2, for example, this is negative, and notice because of the square here, the denominator is always positive. Okay, so we say negative here. And if we substitute in, say, 1/2, again, negative. Okay. Let's say we substitute in a minus 1/2, then this is positive. Okay, this is a minus 1 over here. And if we substitute in minus 2, this will be positive. So we have the function is increasing to the right and left of this asymptote and decreasing to the right and left of this vertical asymptote. All right, let's look at f double prime. Okay, so we're going to differentiate this with the quotient rule. All right, so we square this denominator. So here we have, in the denominator, we have x squared minus 1 to the 4th. Alright, and then we put that denominator of x squared minus 1 squared here, times the derivative of the numerator, that's a minus 2, minus the derivative of this denominator. We need a chain rule here, so we have 2 x squared minus 1 to the 1 times 2x times the numerator of minus 2x. Okay, so that's a chain rule. Now whenever we take the second derivative of a rational function, we can always cancel from numerator to denominator one factor that's in the denominator. So x squared minus 1 can be canceled. Alright, so let's do that. So here in the denominator we have x squared minus 1 cubed, and here we have x squared minus 1 minus 2. Here we have this cancels right here, so we have 2 times 2x times minus 2x. Alright, now how does that simplify in the numerator? Okay, so here we have, this simplifies. Here we have a minus 2x squared, and let's see, and what's this? And here we have a minus, a positive 8x squared, so that gives us a 6x squared, and here we have a plus 2. 6x squared plus 2. Notice this is never 0. This numerator is never 0. It's always positive, in fact, because we have something squared plus a positive number. So that's always positive. Or 0. Always, no, sorry, always positive. It's 2 or greater. 2 or greater. This could be 0, so this sum is 2 or greater. Alright, so f double prime, the f double prime plus minus analysis is done by placing the zeros of the denominator on the number line, and those are minus 1 and 1. Okay, so if we substitute in 2, the denominator is positive. Let's substitute in 0, and the denominator is negative. If we substitute in minus 2, the denominator is positive. So this is, so f is concave up here, concave down here, and concave up here. Now these are not inflection points. These were vertical asymptotes. So we have no inflection. Alright, let's draw a graph, putting all the pieces together. We had the x and y intercept at 0, 0. And remember, 0, 0 was also a maximum. See here, it goes up and down. This is a maximum. That was the only relative max or min was 0, 0. So that's a maximum. Let's put in at 1 and minus 1, we have our vertical asymptotes. Let's put those in. We also had the end behavior. We said that we had a horizontal asymptote at 1. So this function is going to, on the right and left, it's going to level off at y equal to 1. Alright, now let's see, how does this, what happens around the asymptote over here? Well, there are a few ways we can look at it. To the right of this asymptote, either the function is increasing or decreasing. Well, since it's concave up to the right, then this it must be going up here to infinity. All right. So we'll zero in on this arrow. Let me erase the other one. Let me erase, make this a little neater, and erase this one. So we chose the top arrow because the function is concave up to the right of 1. Okay, we can also look at f prime, and we see the function is decreasing to the right of 1, so that makes sense that the arrow should be up there too, decreasing, going down as we go to the right. Okay, between minus 1 and 1 we have concave down. Alright, so that tells us that the asymptotes must look like this. Okay, to the left of 1 going down to minus infinity, and to the right of minus 1 going down to minus infinity. Alright, now here we have the function leveling off to the right. The end behavior is leveling off at 1 to the right, that horizontal asymptote. Alright, now here we have the function is concave up to the left of minus 1, so the asymptote must be here on top. If we're on bottom, it would be concave down, and again leveling off to y equal 1 as x goes to minus infinity. Okay, so that's the graph, and that's the end of the review for test 2. So good luck studying, and I'll see you on Monday.